Hello, hello. We are welcome you on the seminar Overcoming Efficiency Challenges with IoT Data Analytics. And we would like to to check if you can hear and you can hear me and to see my screen. Please press plus if you can see and can hear me. Uh, by that, we will know that you're here, you're present. Please find the chat and just paste plus in that. We will start. Okay. Um, so let us start. You will be able to ask your questions after the meeting. So it's better for you to have the pen and the paper to write down some questions and then to ask them. You can add them into the message panel, and we will answer them in the end of the meeting. Let us start with the presentation. We are happy to present the Trends Analytics seminar for you. A webinar we help to equip you with some useful data that can help you to increase the productivity and to know how you can leverage your IoT data. So first of all, let us start with the agenda. We will talk today. We will talk about the OEE overall equipment effectiveness metrics as one of the critical metrics that can help you to assess the health of your production and how these metrics have changed over time, what new ways of connectivity brought into like this sphere in domain, and how IoT transform the monitoring the OEE metrics. Then we will talk step by step about the implementation strategy that you can take, and we will show the dashboard that can be built with the things board and trends analytics, and we'll show you some particular concrete part how you can create some widgets with visualizations, and we will show you in particular how you can forecast the values and how that can affect your business metrics. We will be talking about the most demanded feature, such as predictive maintenance, and that will help you to avoid this costly downtime and assess uh, the maintenance in the right way. And then we will move on to the Q&A section. So let us start. So first of all, overall equipment effectiveness this term was first coined in 1988, and that was this single metrics that was used as a single source of truth that helps to monitor the health of the production, as I already said, and this single metrics can be calculated and visualized in a table, in the graph, and with progressing of IoT technology, and it can be monitored in the real time. So OEE comprise availability, performance, and quality. And these metrics can be automatically calculated with IoT sensors. So availability is let's break down a little bit these terms. So availability on the smart factory is this time when like the maximum time that you can use for production. The performance is the speed of production, and the factory strives to perform as the fastest speed with the fastest speed to produce more, to face the deadlines, to provide to produce some details in time and on budget. Also, when we're talking about the quality, companies would like to produce only good details. So actually, this OEE is the way to benchmark production and measure manufacturing productivity. A really good OEE score lies generally between 80 and 85%, and perfect OEE score means that you are operating at 100%, that you are manufacturing all parts perfectly as quickly as possible without a stop time. So with now we will just find out more about the details. So here you can see that we need to break down our calendar and map our orders on the facility on the production facilities of our factories, and we can as you can see, we're operating with total schedule time, and we need to take into account the quality losses, uh, the two main difficulties that we can face, and we should take into account it is rejects and reprocess, the performance losses. Uh, we should monitor the micro stoppages and running less than ideal life cycle time. Also, availability losses. We should monitor the equipment utilization. So monitor the reasons why our machinery was in this idle mode, and to eliminate these reasons as soon as possible, right? Then plan the downtime. You can also see that we should have the schedule maintenance, right? And we should avoid this unplanned stops because they are highly costly for the production. As you can see, here are the reasons that we should monitor. Here are the details we should monitor. And as I already said, the OEE is the value that can be represented by the line on the graph. And with this visualization, you can define whether you are doing good, well, or okay. So these what values this can show you uh, the real state of affairs and um, to show you where some corrective actions should be taken. So when we're talking about the, as you can see here, there is this gap between 80 and 40% in OEE score, and it means we are doing something wrong, and we need to improve our strategy to produce more and produce better details, because we have all that we need: machinery, time, uh, employees, but something is wrong on each level, and we should detect the root cause of this inefficiency. But also we have this gap between 80 and 100% of OEE. It means that we can not only improve our production, but we can also find the reserves in time and produce even more. So to be even more smarter and productive, um, and earn more money. Uh, like, right, to decrease our operational cost and increase our production. This is a dream of each smart factory, and not only smart. So here are the action plan, um, what we should monitor, and how we can monitor that with automatically with sensors. Um, Here we should monitor the availability losses, unplanned stop and planned stop. We should monitor the performance losses, check the slow cycles and small stops, and monitor the quality losses. find out more about the percentage of production defects and startup defects. And also it will be good for us to find out the dynamics and correlations between some metrics. So find correlations how some effects from physical world can be monitored and um, adjusted. So efficient way to do that is to assess the trusted data in real time. With IoT technology, you can do that because previously it requires some time-consuming work to collect this data to analyze. There was like the disparate sources, different systems that should be integrated, and it takes hours and months, like quarters, even to assess the state of production and then to take some actions based on that. With IoT technology, you can do that almost in real time. We will show you how that can be applicable. Then you should like reduce this reaction time on each level. When we're talking about levels, we're talking about this management level that needs like this helicopter view. We're talking about the operational operators that often is the firefighters. They should fight some unpleasant stops, machines breakdowns, and it is really important. It is really important to provide this single source of truth for each department in your organization. We would like to move from reactive to proactive management and detect um, some things, some events, prevent the shutdowns from happening. And as I already have mentioned several times, we should take data informed decisions, some actions instead of feelings or expectations. So when we're talking about management, we have some plans and some managerial suggestions, uh, and companies should and operators or employees should work um, uh, upon these suggestions, but sometimes the plans are unreasonable, unrealistic, uh, and from another side, operators can also distort the reality or distort some facts, and that is why we need like the realistic picture, and to do that, it is better to create some dashboard to monitor the metrics. So here are really important and interesting dashboard when we're just presenting the transition from industry 3.0 to industry 4.0. These different layers where we have some management of the plant and some production manager that are accountable for orders, for lines, for plants, supervisor in the front line. And uh, with IoT, you can create the ecosystem that will provide the dashboard for each of them. So each of them can take some decision and enhance the production right away here. Um, so that will decrease the reaction time, and that will uh, affect the bottom line, the budget. You will produce more with less, right? So what actions should be taken when we're talking about the IoT and smart factory? First of all, you should start with some pilot, and you should start with the metrics that you would like to improve. To do that, you can take the some open source IoT platform, trusted. Then use this OEE dash framework to know what you should measure and what you should monitor, and connect the advanced analytics to monitor and translate these input values into some meaningful business values. So first of all, we will connect the wireless smart sensors. They're more or less cheap, and it's cheaper to digitize your production and to gain more with that. So by that you will gain this automating data collections. Then you should measure the current states of affair, current metrics, find out this the source of improvements, right? Some points of improvements where you need to be better, um, and create some strategy to work on that. Then to provide the access to these dashboards to each employee in your organization and department that is responsible for the production, and to act upon that, and then to do some root cause analysis each day to find out how you can be better. So when we're talking about the improving, we're not talking about one life improvement on improvement at once. We're monitoring. We're talking about the lean production, how we can be better on this line and with this process. And as we know, the operators are for example, the best people that know the processes, so they can monitor the process and take some decisions based on the metrics, and we will provide the dashboard for them. We will talk about that later. And managers can look more on the high level and to detect some inefficiency, and then ask their employees uh, to explain how it has happened, and based on that we'll take some decisions. Where should they replace some aging machinery, or should they do the maintenance more often, so something like that. What is like when we have just talked about the steps, and here what can be monitored. If we're talking about, if we are looking at some lines, production lines, here we have visualized it. We're monitoring the simple metrics as rotation speed, energy consumption, vibration, the speed of production, right? The quality of details of items, the temperature of the machine, or something like that. So we are monitoring the values. But with things, boards, and trends, you can visualize them in some meaningful and appealing graphs for the collaborative investigation. So you should define one metric that can correlate with others, and based on that take some test some hypotheses, and by that improve different aspects of OEE. We have already talked about that. So this is how it can look like. We have created the template for the smart factory. So here we visualize the key metrics that should be monitored by manager. So they would like to see this OEE score, availability, performance. They are monitoring the cost of losses that they are responsible for. So they should be ready um, to find out, or to find out how that can be decreased. here we can find this correlation between the uptime and downtime, define the downtime reason and monitor them. For example, in this case, we see that our one of the most popular downtime reason is the standby mode. And on the things board side, we can create the rule one like this to create notification, to create and send notification to the manager, to the operators once the machine is working is staying in the standby mode more than 15 minutes. So some alarm will be created, and uh, this this event will be propagated to the managers, so they can take a decision based on that. So for example, they can spot that some of the machinery um, was in the standby mode and consume a sufficient amount of energy without doing anything. So in next case, they can create the automatic rules to turn off the equipment or to be more productive, uh, to do something with it. So here we're looking, for example, on the representation of OEE by shift, and we see that the first shift is the least productive shift. So we should find out why it is happening, and later we will see how some metrics correlates with the shifts. When we're talking about the table with the machines, right, on the factory floor, one is the one critical metrics that we should monitor is the to find out where we have the bottleneck and when should we like schedule the performance so machines would not be stopped unexpectedly. Um, so we will prevent the shutdowns. In this case, we see that the second machine is the least productive machine, and it means that on some line it is the bottleneck. And once we will eliminate this inefficiency, we will produce more. Also, you can see that uh, like this OEE affected by performance score. And it means that something is wrong with the speed of production. So we need to detect what affects the speed of production to be more effective and find out and enhance the productivity. Here we're looking at the quality dashboard where we can deep dive and look closer at the data by each of aspect of OEE. So here we're looking at the amount of quality score and the amount of errant details, scrap details, or damage details. Here are really good, a crystal clear breakdown about the quality losses. Also, we can see the amount of the errant reasons, and we see that the amount of scraped details is the like the highest source of inefficiency, and we will need to investigate why it is happening. Maybe something correlates with that. So we will get back to that later on our hands-on part. So here we can monitor the amount of errant scrapped and damage details in dynamics and see how that have changed over time. When we're talking about, we have talked about this dashboards for informed decision for different employees or layers. So now we have created the dashboard for operator. Operator is often, as I already said, the firefighter, right? But what they would like, or we should equip them with data, so they will know what to do, like in real time. where now they are facing some problem, and where should they focus on their attention in the future, for example. So here, for example, we are looking at the parts that should be produced and the actual parts. Then we see this gap between the target and our actual uh, speed of production. So it should be adjusted. Yeah, the operator knows that he should do something with that and monitor this metrics closely. Uh, you can see that one of the most critical part on this dashboard, we have highlighted it in red, the quality of details. As you can see, it is suffered, and actual quality is suffered, and we need to find out, the operators need to find out what is happening, why, and on which machine um, the quality um, worsen, so he can do something with that, create some strategy to battle that. Um, so now we will move on to the hands-on part, and we'll show. You can see this dashboards that actual dashboards that can be created with ThingsBoard and Trends Analytics. This that you can filter them. You can deep dive and find out more about your data. Right now, we're looking at availability, the target and actual availability, where we have a gaps. We have this states uptime and downtime per machine, and we see that the first machine is spent more than other machines in this downtime mode. So we need to find out and trigger inspection and find out why it is happening. Also, we can break down the downtime reason per machine and visualize that on the graph, and see that also first machine spent in this standby mode most than other machines. But you can have hundreds of them, and with this simple visualization, you can compare the values. So you can tackle some some particular source of inefficiency, because on the real machinery floor there are multiple, there are like hundreds of machines, and you need to detect this source. So write your questions if you have them in chat. We will be happy to answer. And now I will move on to this hands-on part, where we have been talking about this scraped details, and we would like to find out how um, what affects that. Maybe some some values will show us, right, some insights. So here we're looking at the topology, right, at we are looking at the machines, and we have chosen to create the line chart. We define the state we define the state scrap it, when we calculated sum up the details, and then divide then create the formulas to detect the scraped details from the values, from the input values that we have received from the sensors. Then we add the tool temperature, and we are trying to test the hypothesis that maybe tool temperature affects the amount of scraped details, but we see that it is not there is no clear correlation between them, but maybe we will try to use another value, the tool vibration, and we will spot the correlation between the amount of scraped details and the vibration. So once the vibration will violates the threshold 5.5, the amount of scraped details doubled. And this means that we produce bad details, and we need to reproduce them, or this will definitely affect our budget, and we should do something with that. But now we're already find the root cause of our problem, and we would like to detect when the machine spent how much time the machine spent in that state. So we will add the vibration, right, is high scraping rate. We defined it with the state, and we just choose the duration percent to find out how much time our machines has spent in that state. And as we know, we have a lot of machines, so we can uh, focus on some particular machine to test our hypothesis. We are looking at the amount of scraped details here on different machines, and we will add the tool vibration, the second value, and we'll visualize how they correlates. To do that, we will highlight this time periods when the vibration was higher than our threshold, and now we're able to see that with we even able to define some color zones to distinguish between these states easily. So you can see them now. We are defining the color zone higher than 5.5 as the critical for us. So here we are. We definitely spot the correlation between amount of scraper details and vibration, but we would like to predict the values, to predict how that machine will behaves in the future, to know whether we should replace some details now, or should we wait, or where vibration will be the most critical in the week. So we have chosen the Fourier transformation that is really good in finding out this predicting the seasonality phenomena, and we choose the prediction rate 14 days. And now we will look at the values. And here we look that our machine will operate like if we will proceed production without replacement, we will produce only bad details, scraped details. And it makes sense to stop this machine and to replace um, maybe some engine or some cogs, but to eliminate the source of inefficiency. In this case, for example, we can check the conditions on the other machines, um, and by that, not only to be the firefighters, but to predict some values. Here, we're looking at the representation of predictive maintenance. Right, so here we can see that for the third machine, the vibration level is not so critical, and we can come back to that in the 14 days and see how we will progress with that. Okay, let's move on to the presentation. We have seen this I would say the dashboard for the operator that provide some useful insight for him here and now, what he should do to uh, reach the goal and to reach the plan. So now we will move on. Okay. Yeah. With as we have just looked on that example, when we are monitoring the correlation between the vibration and the damage details, we can create this kind of visualization, the widget where we actually monitor the high vibration score, right? The compare how much time each machine spent in that score, compare them, right? The machine 3 spent more than other machines in that state. We can calculate the amount of scraped details and add money, right? Let's talk numbers, and we will see um, the losses to our budget because we are producing these scraped details, and like sometimes it makes sense to stop the production and to proceed and to replace some details to prevent, as I said, this production of damaged details that we cannot sell or deliver. So we will proceed. Let's move on to some real life examples. Here are inspiring examples from the real factory. This information available online, and here is information for your investigation. That now um, that these companies or factories are working on competitive markets. They are trying to implement digitalization in order to produce more with less operational cost. So and produce like with the best quality to win on the market. So we then General Electric step like start this digitalization. They decided to equip with their lamp producing factory with the smart sensors, and as you can see, they reorient their production process to the like order customer based production process, to this lean process. And they, as you can see, they reduce customer cycle time from 8 to 2 weeks. So they were able to deliver actual order faster. Their plant productivity rises it, like it doubled, and inventory turns went up from 4 to 10%. Here are another example: Airbus factory of the future. Airbus assembly errors rate reduced at 3 times, as they were able to detect the source of inefficiency and eliminate it right away. They reduced the undeliverable parts rate, and line efficiency increased to 98%. So it is really impressive results, and this is the way to follow, like for the forward-looking businesses, factories. So here are the time for Q&As. So the question I would like to answer: how to calculate the score based on the raw readings? It is, thank you for this question. Actually, here we are looking at the Trends Analytics UI, right, user interface. And as you can see, we have been using raw values, this rotation speed, energy consumption, vibration, or temperature or speed of production, to create the formulas, to create this complex virtual values, to translate this values from the physical world, like like we know that time series data is only the timestamp and the value, but with ability to create formulas on top of that, you will be able to translate it to some significant or critical business metrics. So you can see that with drag and drop interface, you are able to add formulas, to use the values uh, to create some states that you would like to monitor in. So in this case, we have created the states standby. We have used the amount of details as the state, for example, to standby state. So if machine not produce anything but consumes energy, it means that it is in standby mode, and we should do something with that. Okay, I will move on to the next question. What predictions functions is available? Are available? Okay, great. So here, what prediction functions? So let me choose. Let me choose, for example, tool vibration and I will show you what prediction function is available in trends. So we have implemented 4 machine learning algorithms. They are supervised machine learning algorithms. It means that you can use the historical data to train your model and then to predict the future values. So here are the 2 types of regression. Linear and OLS linear regressions, then ARIMA machine learning algorithm, and Fourier transformation. As I already said, Fourier transformation is a proven method to detect the seasonality phenomena. All these machine learning algorithms are proven and unproven and popular on the markets. Around the analysis. What is important to mention is that with trend analytics and with ThinkSupport, you're able to apply like this to use this functionality out of the box. So you do not need to write something, but you will be able to add your machine learning model and to visualize that with trends. For example, if you have your own data scientist. But with trends, you do not need to have this data scientist to predict based on your value. We can do that right away. Okay, how we can detect a scraped product and count. Scraped details reported by quality control sensor. In our example, it is optical sensor that analyze image histogram with reference and then report true or false. So we are using the camera to detect the scraped details and count them. Use that. Okay, the next question. How can we reuse presented dashboards in our applications? I'm not sure that I understood the question, but I will try to answer that. So we are working on the unpacking the value of IoT implementation. So now we're creating the templates. Now we are creating the templates that can be deployed on the customer installations. So once you purchase the perpetual or yearly subscription, we will deploy this kind of dashboards, this kind of visualizations. Uh, so in this case, you will be you need to you will need to adjust the widgets like to your customer preferences, to your factory, but you will have some template to start with, something to start with, and then we will guide you how to proceed on, or we will be happy to help you to create modified widgets. Okay. Okay, where the system gets the raw data from. So PLC plus things board gateway, OPC UA, or Modbus protocol. So trans uh, now query things board database with a REST API. And as you can see, we can process heavy calculations on the fly. We don't, you do not need to wait. So there are many other questions, but we are limited in time, so feel free to contact us directly. We will be happy to answer or to customize this presentation for you or to conduct it for your management. We plan to proceed with such series of presentation to educate our customers how to benefit from IoT technology. So feel free to contact us and ask your questions. Thank you for your time. Have a nice day. Bye.